Welcome everyone. In this video, we are going to solve some 13C NMR spectroscopic problems. Question 1. By using 13C NMR, how will you distinguish between para-dichlorobenzene and para-chlorobromobenzene? Let us see the answer. In case of para-dichlorobenzene, there are two sets of carbon atoms. This is the set A, which are the quaternary carbon, and this is the set B. And as there are two sets of carbon atoms, it gives two signals in C13 NMR spectroscopy, that is in CMR. A type of carbon gives singlet, while B type of carbon gives doublet in the spectra. In case of para-chlorobromobenzene, there are four sets of carbon atoms. This is A set, B, C and D. There are four sets of carbon atoms. We get four signals in CMR spectra. A and D gives the singlet, while B and C carbon atoms gives doublet in the spectra. Thus, para-dichlorobenzene and para-chlorobromobenzene can be distinguished with the help of 13C NMR spectra. Question number 2. By using 13C NMR, how will you distinguish between ortho, meta and para-dichlorobenzene? Let us see. This is the structure of ortho-dichlorobenzene. In case of ortho-dichlorobenzene, there are three sets of carbon atoms, A, B and C. The A set carbon atom gives singlet, B set of carbon atom gives doublet, while C gives the doublet in the spectra. Ortho-dichlorobenzene gives three signals in CMR. In case of meta-dichlorobenzene, there are four sets of carbon atoms, A, B, C and D. We know that the carbon atom which has the different electronic and chemical environment are the different set of carbon atoms. And in case of meta-dichlorobenzene, there are four sets of carbon atoms. Therefore, it gives four signals in the spectra. A type of carbon gives doublet, that is a signal of only one carbon. B type of carbon gives singlet. There are two B type of carbon atoms, therefore it is 2C. Then C type of carbon gives doublet, and D type of carbon also gives doublet in the spectra. In case of para-dichlorobenzene, there are only two sets of carbon atoms, A and B. Therefore, it gives two signals in a 13C NMR. A type of carbon gives singlet, B type of carbon gives doublet in the spectra. Thus, ortho-dichlorobenzene, meta-dichlorobenzene and para-dichlorobenzene can be distinguished with the help of 13C NMR. Ortho-dichlorobenzene gives three signals, meta-dichlorobenzene gives four signals, while para-dichlorobenzene gives two signals in CMR. The next example, question number 3, suggests the structures of three isomeric ketones having the molecular formula C5H10O and exhibiting 3, 4 and 5 signals in proton decoupled 13C NMR spectra. In case of proton decoupled spectra, we get singlets in the spectra. The molecular formula C5H10O, there are three isomers. This is isomer number 1, 2 and 3. This isomer number 1, there are three sets of carbon atoms, A, B and C. It is a 3-pentanone and it gives three signals in the CMR. This is isomer number 2. In that case, there are four sets of carbon atoms, A, B, C and D. And it gives four signals in CMR. The isomer 3, in which there are 5 sets of carbon atoms and it gives 5 signals in CMR. That is 2-pentanone A, B, C, D and E. All carbon atoms are non-equivalent, therefore it gives 5 signals in the CMR. Then next example, calculate chemical shift values for aromatic carbons in para-hydroxyacetophenone by using the spectral data. The data given is basic chemical shift value for benzene ring is 128.5, and the group increments are like this. For OH, the group increments are for ipso, ortho and meta and para, group increments are like this. Now we see the solution. This is the para-hydroxy acetophenone. In case of para-hydroxy acetophenone, there are 4 set of carbon atoms. C1, C2 and C6 are equivalent, C3 and C5 are equivalent, and C4. There are 4 set of carbon atoms on benzene ring. Let us see the calculation. For C1, the equation is base plus ipso plus para. This is the carbon atom number 1. In that case, COCH3 group is at ipso position, that is substituent carrying carbon, that is COCH3 at ipso position, while OH group is at para position. Therefore, the equation is base plus ipso plus para. For ipso position, there is a COCH3 group, the increment is 8.9, and OH group is at para position, the increment is minus 7.3. Therefore, the chemical shift value of C1 is 130.1 ppm. For C2 and C6, COCH3 group is at ortho position while OH group is at meta position. Therefore, the equation is base plus ortho plus meta. For ortho, there is a COCH3 group. Therefore, the increment taken is minus 0.1. OH group is at meta position, the increment taken is 1.6, base value is 128.5, therefore the total chemical shift value for C2 and C6 is 129.5 ppm. The chemical shift value of these two carbon atoms is same. Then similarly C3 and C5 are also equivalent. For C3 or C5, OH group is at ortho position and COCH3 group is at para position. Therefore, the equation is base plus meta plus ortho. The base value is 128.5 for aromatic carbons. For at meta position, there is a COCH3 group. The increment value is minus 0.1, and OH group is at ortho position minus 12.7. The chemical shift value becomes 115.7 ppm. For C4, OH group is at ipso position and COCH3 group is at para position. Therefore, the equation is base plus para plus ipso. And by taking increments for para and ipso substituents, the chemical shift value is 161.7 ppm. This chemical shift value also indicates that if oxygen is directly attached to carbon atom, the effect is downfield effect, chemical shift value is more. This is the solution for this question or problem. Then next question, write the structures of two isomeric bromides which have following spectral data. Assign the signals to various carbon atoms in the structures. The molecular formula is C3H5Br. For compound A, there are 3 signals, 32.6, it gives triplet, 118.8, triplet, 134.2, doublet. And for compound B, there are only 2 set of carbon atoms, 12.0 triplet and 16.8 doublet. Then solution. When we calculate the site of unsaturation for this molecular formula C3H5Br, there is a one site of unsaturation, and one site of unsaturation indicates that there should be presence of either double bond or a ring. And when double bond is present, carbon atom is in sp2 hybridization state, and in case of compound A, these two values indicates these two carbon atoms are in sp2 hybridization state. 32.6 triplet indicates it is a CH2 group, and 118.8 also indicates CH2 group, but carbon atom is in sp2 hybridization state. 134.2 doublet indicates presence of CH group, but carbon is in sp2 hybridization state. Therefore, the structure of the compound is CH2 double bond CH, CH2Br. That CH2 group is triplet, CH group gives doublet, and CH2 group gives triplet in the spectra. Therefore, this is the structure for compound A. In case of compound B, there are two sets of carbon atoms, and this chemical shift value indicates that these carbon atoms are in sp3 hybridization state. That is, there should be presence of a ring in the compound. And this is a cyclopropane ring, and the structure is like this. There are two sets of carbon atoms. This is one set and this is the another set. It gives 16.8, it gives doublet. Downfield effect indicates it is attached to bromine, and these CH2 groups are equivalent and they give triplet in the spectra. Therefore, this is the structure for compound B. Both compounds have same molecular formula C3H5Br. Then next example, deduce the structure of organic compound on the basis of following data. Molecular formula is C5H8O and off resonance decoupling signals are 22 quartet, 52 quartet, 125 triplet, 135 singlet, and 168 singlet. This data also indicates that these two carbon atoms are in sp3 hybridization state. This is the signal for CH3 group, this is the signal for CH3 group, and these three carbon atoms are in sp2 hybridization state. And 168, that value indicates there should be presence of carbonyl group in the compound. And therefore structure of the compound is like this: CH2 double bond C CH3 CO CH3. For carbonyl carbon, the chemical shift value is 168 and it gives singlet in the spectra. This is 22 quartet, this is 52 quartet, and these two carbon atoms are sp2 hybridization state. All these three are in sp2 hybridization state, and that carbon gives the signal at 135 and that carbon gives the signal at 125. This is the answer for this question. Question number 7. Predict the product by using given spectral data. This is the reaction and the spectral data of the product is given. The spectral data of product is molecular formula is C10H14O, PMR data 1.26 6H doublet, 2.83 1H multiplet, 3.72 3H singlet, 7.18 2H doublet, and the CMR 24, 33, 59, 115, 127, 141, 153, etc. By using that spectral data, we can assign the structure of the product. 1.26 6H doublet. That signal indicates that there is a presence of isopropyl group. In case of isopropyl group, two methyl groups, that is 6H, are equivalent and they give doublet as they are attached to CH group. 2.83 1H multiplet, it also indicates the signal of methine group proton and attached to two methyl group protons. 3.72 3H singlet, it is the signal for methoxy group proton. This is the signal for methoxy group proton. Also, we remember that in the molecular formula of the product there is no bromine atom. That is, this is the reaction of alkylation and there is a removal of HBr. And by considering all these facts, the structure of the product is like this. The signals are assigned for both PMR and CMR. For sp2 hybridized carbon, the signals are above 115 and these are the sp3 hybridized carbon atom. And for methoxy carbon, the signal is at downfield which is at 59. Similarly, we can predict the signals for PMR also. That are the chemical shift values of PMR. Thus, in this video we discuss the different types of CMR spectroscopic problems. Thank you very much.